This video will cover some text processing functions as part of the Tidyverse. The R code and data used in this video are available on the Learning Management System. The data file is hourlyweather2017.rds. You should download these now if you'd like to follow along. By the end of this video, you should know what library is provided by the Tidyverse for processing text data, and what are some important text processing functions and how are they used. R has substantial facilities for dealing with strings or text data. There are some built-in functions like paste. There's an expansive library called string_i that provides many very low-level and detailed text processing functions. There's also the smaller and easier to use library string_r. String_r is what I'll cover in this class. It's designed to work with the Tidyverse and Tibbles. If there's ever a problem that you have that you can't solve with the string_r library, it's worth taking a look at the string_i library to see if it has what you need. String_r is part of the Tidyverse and loaded when you load the Tidyverse library. So let's cover some of the features of the string_r library. First off, it provides useful functions for adjusting the case of text. These are very handy when you're wrangling data. Frequently text might be miscoded or capitalization might be inconsistent. There are three major functions. The string_to_lower function will convert your text to lowercase. The string_to_upper function will convert your text to uppercase. And then string_to_title will convert your text to title case, where the first letter of each word is a capital and the rest are lowercase. We can get some practice using these functions in R. Remember that the string_r library is part of the Tidyverse, so it's loaded by my setup code that loads the Tidyverse. So here I have some examples of string_r functions that change the capitalization of my string that has very weird capitalization. Remember there's string_to_lower, string_to_upper, and string_to_title. Each one takes one argument, which is a piece of text, in this case my variable example string. Let's run all of that and see what we get. Looking in the output window, you see the result of string_to_lower is that string now is all in lowercase. String_to_upper gives you the text in uppercase, and string_to_title gives you title case, where the first letter of each word is capital and the rest are lowercase. String_r provides some other handy utility functions for dealing with strings. The first is string_c. This combines strings. It accepts an arbitrary number of arguments, as many as you'd like. It combines all of them into a single string in the order that you specify them. It attempts to convert each argument to text before combining it into a string. So if you provide numeric data, it will convert that into the corresponding piece of text before combining it. There is no default separator between each of these segments. If you'd like to put a piece of text between each of the arguments, you can change the separator with the sep equals argument. String_dup creates repeating patterns of text. It takes two arguments. The first is a piece of text, a string, and the second is a number. And what it will do is return a string that repeats that first argument the number of times specified in number. There is also string_length. This returns the number of characters in a string as an integer. You provided a single argument, which is a piece of text. It's going to count all of the characters, even spaces, new lines, and punctuation. Importantly, escape sequences count as one character, so a \t represents a tab. It's going to be counted as one character when computing the length of the string. So let's look at some of these functions in R. I'm going to define two variables, example.1 and example.2, which will hold the strings hello and world. I can use the string_c function to combine them. You'll notice the output smashes those two strings together. By default, there's no separator between each argument, so here I get hello and world with no space between them. If I'd like a space in between, I can use the sep argument. Here I've specified the sep argument as a space, and you see I get hello world with a space in between. There's also the string_dup function. Remember, this duplicates patterns of strings provided in the first argument. Here in this example, I've specified the string to repeat as hello with an exclamation point and a space afterwards. I specify 5 as the number of times I'd like it repeated, and you see my resulting string is hello 5 times with a space afterwards. There's also the string_length function. This tells you the number of characters in a string. As a first example, I can calculate the length of the string hello. That's 5 characters long, so the result is 5. If you remember, I stored this string has weird capitalization in my variable example string. If I were to compute the length of that, it comes out to be 36. A frequent data wrangling task you'll deal with is removing excess white space from your strings. White space is anything that prints as a space, so you can think of the space, a tab, a new line, or some other weird characters, they all count as white space. The string trim function removes white space from the start and the end of strings. The default is to take white space off both the start and the end of the string. You can provide the optional argument side equal to, either left or right, to only remove the white space on one side of the string. There's also the string squish function. String squish will remove white space from both the start and the end of your string, and will collapse white space inside of your strings. If there are repeated spaces, for example, they'll be collapsed down to a single space. I have some examples of dealing with white space in strings. So first I'm going to define a variable, example string. You can see it has a bunch of excess spaces in it. I can remove all of the leading and trailing white space with the string trim function. You can see the result is that the spaces at the beginning and the end have been removed. There's also the optional side argument, left or right. You can see in the case of side equals left, it removes only the white space on the left, and side equals right, it removes the white space only on the right. To demonstrate string squish, I'll use an even more complicated string. Here, example string has some tabs and some spaces in it as well. If I print it out, you can see there are sequences of tabs, a new line, and several extra spaces as well. String squish removes white space from the start and the end of the string, and compresses every sequence of white space characters into a single character within the string. Looking at the result here, all the tabs have been converted into a single space, as has the new line, and the spaces at the end of the string have been removed as well. Sometimes you may only want part of a string. The string sub function allows you to extract substrings from an existing string. It takes 3 arguments: the string that you'd like to process, the starting character, and the ending character. String sub will then return characters numbered start to end from that string. If you specify an end that is before start, R is going to return the empty string, so double quotes, not an NA. If end is after the end of the string, it's just going to return from start to the end of the string. If start is after the end of the string, R again will return an empty string. If you put negative values in for start or end, R is going to count from the end of the string as opposed to counting from the beginning. I have several examples of the string sub function. In all of them, I'm just going to use the alphabet in uppercase. In my first example, I'll take characters 5 through 10 from the alphabet, and you can see the result is E, F, G, H, I, and J, the 5th through the 10th character in that string. Next, I specify the starting position as 5 and the ending position as 3. Remember, if the end is before the start, R just returns the empty string, and that's what I get here. In my next example, I specify the starting position as 25, the ending position is 30. There are only 26 characters in this string, so R gives me from the starting position, which is the letter Y at 25, until the end of the string, which is the 26th character, Z. In my last example, I specify the starting position as -5 and the ending position is -2. In this case, R counts backwards from the end of the string, starting with the 5th character from the end of the string, which was V, and ending with the 2nd character from the end of the string, which was Y.